Hello everyone, I am Yu Huang from the MSTP LMT department. I'll introduce packet services supported by OSN devices in this course. First, let me introduce some basic concepts. An MPLS network is a network area that consists of interconnected LSRs. An LSR is a network device that performs label switching and packet forwarding. A typical MPLS network is shown in this slide. LSRs that reside at the edge of the MPLS domain are called LERs, and LSRs within the MPLS domain are core LSRs. MPLS runs on neighboring core LSRs. On an MPLS network, an LSR uses the same label switching mechanism to forward packets with the same characteristic. The packets with the same characteristic are called a forwarding equivalence class, FEC. The path along which an FEC travels through the MPLS network is called an LSP. LSP is a unidirectional path. Ingress is the start node of an LSP, and it encapsulates a label into a packet and forwards the MPLS packet. Transit is the intermediate node of an LSP, and it performs label switching and MPLS packet forwarding. Egress is the last node of an LSP, and it removes the label and recovers the packet for forwarding. An LSR ID is allocated to the LSP so that the upper layer application, an MPLS tunnel, can invoke the LSP. An LSP ID is locally significant. An MPLS tunnel on an OSN device has only one LSP. Therefore, an LSP ID is the MPLS tunnel ID. PWE3 is a Layer 2 service bearer technology that emulates services such as Ethernet, TDM, ATM-IMA on a packet network. The PWE3 network model is shown in this slide. PWs are set up between PEs to provide access for CE services. A tunnel is set up between PEs to carry PW services. The service direction from CE1 to CE2 is used as an example. The service process is as follows. CE1 transmits the service to PE1. Then PE1 encapsulates PW and tunnel labels into the service and forwards MPLS packets. PE2 decapsulates the tunnel and PW labels and then transmits the services to CE2. The PWE3 encapsulation format is shown in this slide. Tunnel labels are used to identify tunnels, and PW labels are used to identify PWs. The control word is used to check the packet sequence, fragment packets, and reassemble packets. Its format is determined by the service type carried by PWE3 and the encapsulation mode. Now let's learn the eLine service. eLine services can be classified into UNI eLine services and UNI NNI eLine services. UNI NNI services can be carried over ports, PWs, or Q-in-Q links. The UNI eLine service is the local service. For eLine services carried over ports, PEs forward Ethernet services over ports. For eLine services carried over PWs, PEs forward services over PWs carried by a tunnel. For eLine services carried over Q-in-Q links, Q-in-Q links are set up between PEs, and an SVLAN tag can be added to user packets. The table in this slide lists models of eLine service carried over PWs. For the Port plus C VLAN mode, the user packet carries a C VLAN tag. The access port of PE services, which identifies and processes the C VLAN tag, must be set to 802.1Q. For the Port plus S VLAN mode, the user packet carries two C VLAN tags, whose outer VLAN tag is the S VLAN tag. The access port of PE services, which identifies and processes the S VLAN tag, must be set to Q-in-Q. For the port mode, the encapsulation type of the service port is set according to the type of the user packet. Encapsulation types such as null, 802.1Q, and Q-in-Q are supported. Null indicates that user packets are encapsulated directly without identifying and processing the packets. PW that carries the Ethernet service is called Ethernet PWE3. Now, let me introduce the concepts about the Ethernet PWE3 packet forwarding process. The service demarcation tag indicates the user access mode, that is, the encapsulation mode of the user Ethernet service. The service demarcation tag is classified into two types, user and service. The PW encapsulation mode indicates the mode used to encapsulate Ethernet frames to PW services and is classified into two modes, raw and tag. Now, let me introduce the process of Ethernet PWE3 services. The service demarcation tag is user. If the PW encapsulation mode is set to raw and a packet enters a PW, the PE directly encapsulates the packet into the PW. When the packet leaves the PW, the PE decapsulates PW and then transmits the packet to the CE. If the PW encapsulation mode is set to tag and a packet enters a PW, the PE adds a service VLAN tag into the packet and then encapsulates the packet into the PW. When the packet leaves the PW, the PE decapsulates the PW, removes the service VLAN tag, and then transmits the packet to the CE. The service demarcation tag is service. The outer VLAN tag of the user packet is service VLAN tag. If the user packet does not have a VLAN tag, the default SVLAN1 tag is added. If the PW encapsulation mode is set to raw and a packet enters a PW, the PE directly removes the VLAN tag of the packet and then encapsulates the packet into the PW. When the packet leaves the PW, the PE decapsulates the PW, adds a VLAN tag according to the service port settings, and then transmits the packet to the CE. If the PW encapsulation mode is set to tag and a packet enters a PW, the PE removes the VLAN tag of the packet, adds a service VLAN tag into the packet, and then encapsulates the packet into the PW. When the packet leaves the PW, the PE decapsulates the PW, adds a VLAN tag according to the service port settings, and then transmits the packet to the CE. Now, let me introduce the eLAN service. eLAN service can be carried over ports, PWs, and Q-in-Q links. For eLAN services carried over ports, PEs forward Ethernet services over ports. For eLAN services carried over PWs, PEs forward services over PWs carried by a tunnel. For eLAN services carried over Q-in-Q links are set up between PEs, and an SVLAN tag can be added to user packets. The packet forwarding process of eLAN services carried over PWs is the same as that of eLine services. The table in this slide lists models of eLAN services carried over PWs. C-aware indicates MAC address learning based on CVLAN tags. S-aware indicates MAC address learning based on SVLAN tags. Tag transparent indicates that when the encapsulation type of a port is set to null, any Ethernet packets can be transparently transmitted. SVL indicates shared learning among VLANs. In this mode, all VLANs share the same MAC address forwarding table, and the MAC address in this forwarding table is unique. IVL indicates independent learning among VLANs. In this mode, VLANs have independent MAC address tables, and the MAC address tables of different VLANs can have identical MAC addresses. That's all for the course. I believe you have gained a further understanding of eLine and eLAN services. Thank you.